Okay, so today I want to continue with chapter 2, namely section 2.6, transformation of functions. So how do we use the basic graph to get more sophisticated graphs? Okay, let y equals of f of x be the basic graph. Basic graph to graph more complicated graphs. We do the following steps. Okay, now the basic graphs that I want you to know, actually, since you have a graphing calculator, you can easily retrieve these. But anyways, these are the basic graphs. The U-shaped y equals x squared. Everybody should know how to do this by heart. It's simple, making a t-chart. And then the V-shaped absolute value of x. And then the square root of x shape, which starts at 0, 0 and infinitely this way. The no shape, the increasing shape, y equals x cubed. Y equals x, which is also called the first bisector. It bisects the first quadrant. And then y equals cube root of x. Okay, this handout is page 19 in the note on section 2.6. Okay, so it's included in the notes. If you go over last notes, it's in there. It might also be under handouts, but I'm not sure. I can't remember. But I know it's in the class notes, page 19. Okay. Now, these are the steps for transformation of functions. Again, remember y equals f of x is the basic graph. Okay, is the basic graph. So the graph y equals f of x plus c, where c is positive, you're going to shift f of x up c units. If it's minus c, it's going to go down units. Again, f of x is your y value, so you're adding c to every y value, it goes up c. Subtracting c from each y value, so it goes down c. When the plus and the minus are inside the parentheses, they're applied to x, so it's going to shift size. It'll be opposite to the sign. A plus shifts it to the left, and a minus shifts it to the right. Okay? When it's inside the parentheses or inside absolute value or inside the square root, inside parentheses, inside absolute value, inside square root, it's going to shift opposite to the sign. A plus makes it shift to the left, minus makes it shift to the right, as many units as c is. When you have f of negative x, it's a reflection about the y-axis. We're going to see examples about all these. When you have negative f of x, it's a reflection about the x-axis. Then there's stretching and shrinking. If you have a constant times f of x, like 2x squared or 2 square root of x, if c is between 0 and 1, it's vertical shrinking. And if c is greater than 1, it's vertical stretching of the original function. It's multiplying y values by c. That's what it is. If you're multiplying if the c is times x inside the parentheses, then it's going to be horizontal stretching. Stretching if c is between 0 and 1, and vertical or the horizontal stretching if c is between 0 and 1, and then horizontal shrinking if c is greater than 1. So we're going to keep, again, this handout is in the notes, number 20 in your notes on that section. We're going to keep this handy as we see examples, okay? So, for example, if you start the basic graph, which we all should know by heart, y equals square root of x. Well, to graph it, if you forgot, x can only be 0 or more, so 0, 0, 1, 1, 4, 2, 9, 3, and the graph is going to be 0, 0, 1, 1, 4, 2, and then 9, 3, so it's going to go in that direction. That's one of the big graphs of the handout that you have. Okay, now based on this basic graph, we can do more complicated graphs. If you look at number 2, again, these are all in your notes, okay? Y equals, I'm looking at numbers, page 17 in your notes. F, so this is like having f of x minus 2. The minus 2 is inside the parentheses, so it's going to go opposite to the sign. It's going to go move to the right 2. So if you look at the basic graph, which started at 0, 0, it's going to go to the right 2. So it's going to start at 2, 0, and then copy and paste the basic graph. And you can see that this makes sense because if you put in a 0 for a 2 for x, 2 minus 2 is 0, y is 0. So you have moved the right way. Number 3, y equals, now you can see square root of x plus 2. This is f of x plus c, where c is positive. So you're going to move up 2. Again, you start with the basic point, 0, 0. You move it up 2, so you're at 0, 2. And then you copy and paste. That's all you need to do. Number 4. If you have y equals square root of x minus 2 plus 3. So there's a shifting inside the square root, which is right 2. It's opposite to the sign. And this is up 3. So we start at 0, 0. We go right 2, up 3. And we copy and paste the basic graph. Okay. Number 5, we have y equals negative root x. That's like negative f of x, right? Right there. You have negative f of x. You reflect f of x about the x-axis. So I'm going to do the basic graph. Zoom out. Okay, so I'm going to do the basic graph. Dotted, so we know what we're reflecting. So we're going to take the basic graph and reflect it along the so it's a minus f of x, so it's going to be reflected about the x-axis. So this is the x-axis, so it's going to go like this. This would be y equals negative root x. And number 6, y equals 2 square root of x. This is like having c times fx. So if you look at the handout, c times f of x, when c is greater than 1, we have vertical stretching of f of x. Vertical stretching by 2 units. So the basic graph is this. You go vertical stretching, so it's somewhat like this. Okay, you vertical, so y equals 2 root x. And if you have number 7, y equals 1/2 root x, that's c f of x, but c is between 0 and 1. Then c f of x, c between, so you have vertical shrinking of c f of x, so vertical of f of x, so it's gonna go like this, shrunk by 1/2. And number 8, if you have y equals square root of 2x, so this is like f of cx, where c is greater than 1. When c is greater than 1, you have horizontal shrinking of, so horizontally you shrink it, it's like compressing it horizontally. So it's gonna go like y equals square root of 2x. Okay, you compress it horizontally, so that's what you get. And if you have number 9, which is on page 18 of the notes, y equals square root of 1/2 x, which is f of 1/2 x. That's c. C is between 0 and 1. F of cx, so you're gonna stretch it horizontally. y equals square root of 1/2 x. You can always make t tables just to see it, okay? And number 10, if you have y equals square root of negative x, that's f of negative x, which is a reflection about the y-axis. So instead of going this way, it's gonna go that way. Okay. And if you have f of x equals negative 2 square root of x plus 3 plus 1, okay, so when you have multiple shifting, this is what the hand is for. You're going to do horizontal shifting, which is inside the parentheses or the square root or the absolute value, then stretching or shrinking, then reflecting, then vertical shifting, okay, in that order. Horizontal, then shrinking or stretching, then reflecting, then vertical, okay? Do it in that order. So we're going to do left 3. That's the first thing we're going to do. Then we're going to do the vertical stretching, because like c f of x, and c is greater than 1. And then the negative is deflection, negative f of x in the x-axis. And this would, so 1, 2, 3, and this is up 1. So in that order, 3, start with left 3, and then vertical stretch. So instead of being like this, it's gonna go higher, vertical stretching, and then reflecting in the x-axis. So instead of going this way, it's gonna go that way, but then down 1. So this would be the final outcome. X plus 3. Oh, I'm sorry, up 1. This would have been down 1, sorry. Yeah, so it's instead of being down here, it would be up there. So that would be your final outcome. Negative 2 square root of x plus 3 plus 1. Okay, here's another example. F of x equals negative 2x plus 1 square minus 2. Since we have a square, not square root or absolute value, it's going to be a U-shaped, okay? It's going to be U-shaped. So we're going to go inside the parentheses, left 1, and then we're going to shrink horizontally, and then reflection about the y-axis, because that's f of negative x, and then down 2. So 1, 2, 3, okay, and it's gonna have a U shape or upside down U shape. So the first step is to go left 1, so instead of being U shape at 0, 0, it'll be U shape at negative 1, 0, left 1, and then shrink horizontally. So you shrink it horizontally so it becomes a little narrower like this. This would be step 2. And then you reflect about the y-axis. So it's gonna be, this is gonna be that. I mean, I'm not being accurate here, but it's okay. And then reflecting, and then down 2. So this would be your final outcome, 1, negative 2. Okay, let's look at page 207, number 70. So practice those, please. Page 207, number 70. And that's the beauty of number 70, because you cannot use the calculator on that. And I might have something like this on the test, where you cannot just punch it in the calculator and give me the answer, okay? So if you look at number 70, it says, the graph of f of x is given, match each equation with its graph. So part A, you gotta look at you're gonna look at the chart and see which one 1/3 f of x. F of x is the one in blue, it's upside down, 1/3, so c times f of x. So basically you're going to if you times it by a number between 0 and 1, it's gonna shrink vertically. Look at what I'm talking about right here. So we're doing c f of x. When c is between 0 and 1, it's gonna shrink vertically. That's what I'm talking about, okay? So what's c f of x? What's 1/3 f of x shrinked vertically? It's gonna be the same size. So it looks like, I would say it looks like number 2, okay? It shrunk vertically, number 2. So A is 2. Now look at B. B is negative f of x plus 4. So it's moved left 4. And then reflection in the x-axis. So if you look at the blue graph, shifted 4 to the left. And then you reflected in the x-axis, 4 to the left, and reflected in the x-axis. So let's see, 4 to the left, 1, 2, 3, 4, and reflected in the x-axis. The only one that's gonna match is 3 here. Okay, so B is 3. Let's look at C. Y equals f of x minus 4 plus 3. Please look at the graph while we're doing this. Right 4 and then up 3. So the blue graph, it's gonna go right 4, 1, 2, 3, 4. Obviously 1 is the only one that's gonna match that. And then D is, what's left for D is 4, okay? Even without thinking about it. And last thing we need to do in section 2.6 is even and odd functions. Even and odd functions. Let y equals f of x be a given function. So we know what that is. If f is an even function, when we say even function, that means its graph is symmetrical about the y-axis. Okay, an even function has a graph symmetrical about the y-axis if f of negative x equals f of x for all x in the domain of f. What that means, for any x, like if you pick 1 and negative 1, x and negative x, you get the same y value for either one of them. This is f of 1 and f of negative 1. You pick 2 and negative 2, then you get the same y value. That's why you get symmetry about the y, okay? When you plot these points, you get symmetry about the y-axis. So by changing the x into its opposite, the y value stays the same. By changing x into the opposite, the y value stays the same. Here's an example. Like if you look at f of x equals negative x to the 4 plus x squared minus 2. If you find f of negative x, if you change x into its opposite, let's do that. Negative is originally there. Then we're gonna put a negative x for every x and evaluate it. If you do negative x squared, it says x squared, and then you bring this down, plus that's all x squared, which gives me exactly f of x. That's why f is an even function. If you graph it, you're gonna see the graph is symmetrical about the y-axis. So let's delete what's in there and graph negative x to the power 4 plus x squared plus x squared minus 2 and graph it, and you get a graph that's symmetrical, obviously, of the y-axis. Okay, now there's what we call odd functions. F is an odd function. Graphically speaking, its graph is symmetrical about not the x-axis. It won't be a function. Okay, it's about the origin. It's symmetrical about the origin. If you have x and you take its opposite and you find the y value for the opposite, it's not going to equal the y value. It's going to be the opposite of the y of the original one. Okay, f of negative x is negative x, which means if you pick 1 and negative 1, they don't have the same y value. If this is f of 1, then f of negative 1 is going to be the opposite. If this is f of 2, then f of negative 2 is minus x, and you find f of negative x, get negative x cubed minus negative x cubed plus x, which is negative the quantity x cubed minus x, which is, that's why we have an odd function. And if you graph it, it's going to have a graph symmetric about the origin. Usually, when you have all odd exponents of the variable, it's an odd function. If you have all even exponents of the variable, 2 has an exponent x to the 0, which is even also. If it's all even, it's an even function. If it's all odd exponents, it's odd function. Now, this is for polynomials. For anything else, that doesn't work. Okay, we're gonna. If it's a mixture of even and odd, then it's neither odd nor even. Okay, and that's it for 2.